Okay, we have another integral from the MIT Integration Bee 2025, number 9. We have the integral from 0 to 1, x to the 2024, 1 minus x to the 2025 to the 2025 dx. Okay, I can think of exactly 3 different ways to do it. You may recognize this as a form of the beta function. So that would probably be the fastest way, go right to the formula and plug in. Because even though it's not used as much, there is a form of the beta function with an exponent here. But usually the way we see the beta function is this right here. We want this to just be 1 minus x. So I think what I'll do is the 2 other methods I have in mind. One of it is getting it looking like the beta function that we're more familiar with. So in order to do that, all I need to do is let's do a u substitution for this. So we'll set u equal to 2025, take a derivative, power rule, we get 2025x 2024 dx. And now the nice thing about that is we already have x to the 2024, we have it right there. I can create this 2025 just multiplying in right there. Look, 2025, 2025, 2025, 2025. So now go ahead and substitute. We'll have this constant value in front, plug in. The nice thing about 1 and 0 is they don't really change. So you plug in 1, you get 1. You plug in 0, you get 0. X, we're not going to look at this because what we're doing is I'm going to group this with this to get our du value. So we'll look at this part, and this is going to become 1 minus u to the 2025, and everything else is du. And then it's actually from this point that I have 2 methods. So we won't go back to the original problem. We'll start at this point, and I've got 2 different ways to do this. They're both, I mean, at this point it's really quick, so it doesn't really matter too much what you do. But let's do the beta function on it first. So we can look at this. I can create a u right here, even though it's just a 1. And in order to do that, I'll write it like this. So we have u to the 1 minus 1, or 0, which is just going to be a 1. For this over here, 2025, I can write this as 2026 minus 1. And then what happened is this is set up for the beta function where our input is going to be 1 in 2026. So what's going to happen, we still have a constant out front. And so actually to make it clear, like in this notation, this is the same thing as beta 1, 2026. Writing this in terms of the gamma function, we get gamma 1, gamma 2026 over the sum of these 2 values, which is going to be gamma 2027. We still have this here. Then we can reduce this a couple different ways. For gamma of n plus 1, that's the same thing as n factorial. We have all integer values, so we could use this. We also can use gamma n plus 1 equal to n gamma n. So on this first part, if gamma of 1, that's going to be 0 factorial or 1, that goes away. Maybe what I can do, we don't really need to use factorials again. I mean, you can, it doesn't really matter, but let's do this. Using the bottom formula, what's going to happen with this is I can write gamma 2027 as 2026 times reduced by 1, gamma 2026. But then the gamma functions are going to cancel, and we're left with our final solution of just 1 over 2025 times 2026, and that's it. But now let me just backtrack, and we'll do this without using the beta function really quick. That one is going to be easy as well. I noticed that sometimes people would rather not use the beta function or the gamma function or Laplace transforms, or even last video, King's principle. I think because in calculus class you don't actually learn those methods, so it's kind of easier to just do u substitution and stuff, and that's what we can do here. And you actually could probably just do it in your head because you've just got a pretty simple substitution here, but let's just do it out because it's going to be more clear with the minus sign, I think. So I'll substitute t for 1 minus u, so we'll set t 1 minus u, then dt is going to be minus du. Do a substitution on it. What's going to happen, you plug in 1, you get 0. You plug in 0, you get 1. Then we're going to have here t 2025 minus dt. But I can take the minus and flip our bounds around. Then go ahead and integrate it. We still have our 1 over 2025 in front. Power rule, we get t 2026 over 2026. Plug stuff in. The 0 is going to be nothing. You plug in 1 for our final solution on it. We get 1 over 2025 times 2026, and that's it. I don't want to write it up, but I'll show a screenshot of that formula that if you wanted to do it out, you know what I can do for the first method, I can assign it as homework, because I've seen people do that in videos before. So your homework will be do it with the beta function using the formula. Okay, that's it for today. Thanks everyone for watching. Have a good day.